talk to you about two of my favorite things. The first favorite thing is nanotechnology, the amazing ability to understand and to view and to manipulate the world at the molecular and atomic level. The second thing is one of my favorite experiments. It deals with surface area. And surface area is an extremely important property when you're dealing with the nanoscale. In fact, surface area is the reason that we can use a smaller amount of platinum, for example, in catalytic converters, because we can make the pieces of platinum smaller and smaller, increase the surface area for the same amount or volume of platinum, but use less. Chemical reactions are dependent upon the surface area, how much of one surface is in contact with another, or how much of one chemical is in contact with another one. And for example, our tongue is a perfect example of the value and importance of surface area. You know, our tongue is not a flat surface. It has all those little tiny taste buds. And actually, if we took the surface area of all of those taste buds on our tongue and could lay them flat, it would be about 200 square centimeters of area. Our tongue is certainly not that big, but because we have all of the little taste buds and the bumps increasing the active surface area of our tongue, we can taste things like salt and sugar, lemon juice. But that's the importance of surface area. And so one of my favorite activities that involves surface area and nanotechnology, I've modified a bit to include some of the next generation science standards requirements. And as an educator, I'd like to share some of those changes and that process with you. So the first thing that we want to do is talk about the experiment itself. It's pretty straightforward and simple. And during this time of hybrid education, this is actually an activity that your students can do at home, and then perhaps on a Zoom or combinatoria group meeting, they can share their data and you can lead them into new insights. So this experiment, just at a high level review, you take Alka-Seltzer tablets, you need some water, and then you need a timer. A stopwatch, which most of us have on our cell phones, easily acceptable. What you want to do is have the students take the Alka-Seltzer tablets and break them up into different numbers of pieces. So they'll have one entire whole tablet, another one may be broken into 4 pieces, and maybe some of them would want to take a mortar and pestle and grind a tablet into powder. And I have another video that explains for your students how to do this activity in more detail. But basically, you take different pieces of Alka-Seltzer or Alka-Seltzer tablets that have been broken up into different pieces. Those different pieces are going to have different surface areas. And what you will find is that the time for different numbers of pieces to dissolve is a little bit different for each, dependent upon the number of pieces. And it's certainly different between a whole tablet and the powdered tablet. So once your students do that experiment, then you can either have them send you the information, but what you want to do is you want to create a table that just has, pretty simply, the number of pieces and the time to dissolve. Now, dissolve. One of the things that I thought was very interesting, and it's one of the soft skills, is when I had my students in a lab and I would have them in groups, and different groups would be doing the experiments themselves and measuring the time to dissolve. And then I would go to the whiteboard and I'd say, okay, team 1, what was the time to dissolve for one tablet, 2 tablets, or 2 pieces, so on. And I'd end up with a whole bunch of times. And the thing that we learned was that, oh my gosh, some student groups would take over a minute for a tablet to dissolve, while others would measure 45 seconds or 37 seconds, some completely different number. And so through a little bit of interesting conversation, I kind of got the students to realize that not all of the groups had the same definition for dissolve. Some of them thought it was dissolved when you saw no more bubbles coming up to the surface of your container, to the surface of the water. Other groups define dissolve as, hey, when we can't see any more of the white tablet in the bottom of the cup. So one thing my class had to do was define the definition of dissolve. And this is something that's critical in the career or in the industry world. When you're talking to someone else, you need to make sure, or to a team, you need to make sure that everybody has the same definition of the constraints or the properties or the process that you're following. So it was kind of a fun activity and a fun experience for my students. And I bet if you pull your students together and you start trying to get the data from multiple students, that you're going to end up with a very wide range of times. And that's because I bet your different students are going to have a different definition of what they mean to dissolve. So we can take the surface area, the number of pieces, and you can also create, I have another chart of the number of pieces, 1, 2, 4, 6, powder, and then the surface area, which you can add in different columns for the equations, which is what I did. I had like the number of pieces and then the surface area of an entire, a whole tablet, and then kept calculating and measuring the surface area. And of course the tablets are circular, and so the surface area on the top and the bottom is going to be pi r squared, and you can measure the diameter and calculate r, and the circumference, the area around the edge, is going to be 2 pi r, where that's going to give you the length around the circumference, and then they need to measure the thickness of the tablet. And in the video that I've done for the students, I have another one, a second video that shows them how to walk through the measurements, and I can show them how to do the calculations. Again, this is a case where you can have your students do the calculations themselves. They can use an Excel spreadsheet, or they can do it by hand with a calculator and a hand calculator. And again, this is a place where once you pull your students, when you're able to, either in a Zoom meeting or actually in a face-to-face classroom, they can compare their results. And you're going to have students that are going to pick different numbers of pieces to break their Alka-Seltzer tablet into. So this is just a real opportunity to either do a hand-calculated table or learn some Excel capabilities. So that was just really a lot of fun to have the students look at the different variations. You can also calculate the percentage change in time to dissolve between the different types of tablets. Again, that gives your students a little bit of math experience, calculating the percentage difference, or actually it's the percentage increase or decrease in time to dissolve as you keep breaking your Alka-Seltzer tablet up into smaller entities or larger numbers of pieces. Again, have them calculate that percentage change in the surface area. So you've got our table, we've got number of pieces versus time to dissolve, and what I usually have my students then do, and this is kind of the fun part, is draw a graph and map out number of pieces versus time to dissolve. Oops. And this is going to be in seconds. And so what you're going to get is a chart that looks something like that with the different numbers of pieces. So again, this is an opportunity. If you have the ability to pull information from multiple students, you're going to have different numbers. And so you can actually, depending upon the grade of the students, you can determine error bars or variations in terms of the time to dissolve that was measured by your different students. Again, a place that you can enhance the math aspect of this activity. So we create a chart that's got time to dissolve versus number of pieces. And again, this is something that the students can do using the Excel spreadsheet, or they can draw the graph by hand. Your choice, however you would like to have your students do it. And again, it depends upon the grade level of the students and what you want to accomplish. Now, the next fun part is, okay, students, you did a whole piece, 2 pieces, 5 pieces, and the powder. So they had 7 data points, or 4 data points. And so now what you do is you say, what if you had 6 pieces or a different surface area? So you can go to this chart, pick the location where 6 pieces might be on the graph, and end up predicting a time to dissolve for that number of pieces. So you want to pick a number of pieces and different students are going to have different numbers, but you want to pick number of pieces that they didn't do before. And so you use the graphical data to predict the time to dissolve for that number of pieces. Then, of course, being good scientists and engineers, we're going to try it. So get a piece of the Alka-Seltzer tablet and break it into that number of pieces. Do the measurement. Maybe you want to do the measurement 1 or 2 times to get different values or get a certain assessment of the amount of variation. Or again, if you've got a group of students that are pooling all of their data together, you're going to have the richness and the depth of all that variety of different values that the students are going to measure. And so you can use that either way. If it's a single student looking at their own experiment and with those types of blinders on, then maybe they want to do the experiment more than once. It's a good thing that those Alka-Seltzer tablets come 36 in a box, so you've got lots of opportunity to do a lot of variations. I want to just mention that in addition to calculating or graphing time to dissolve versus number of pieces, you can also graph time to dissolve versus surface area, which is going to be directly correlated with the number of pieces that you've got. And each time you break that tablet up, you're adding not necessarily more surface area on the top or the bottom, but you're adding more of that edge area that the students can measure the length, and you know the thickness, and you can calculate that added area because you've broken that tablet. So this experiment, although very simply done for basic, smaller, younger grade students, have them do a whole tablet, powder, and break it in 2, and look at the difference that changing the surface area does to the time it takes for that tablet to dissolve. For some of the higher grade levels, you can have them do multiple variations. You can have them create their tables. You can have them work in the Excel spreadsheets. You can have them do the statistics and calculate the probability, not probability, but percentage change for difference in surface area, difference in time to dissolve. Make sure they all have a common definition of dissolve. That was really fun. I still laugh when I remember my students going, no, it's not a minute, it's 37 seconds. And they would almost start arguing about why their times were more accurate than their other classmates. But I would just like to encourage you to try this experiment. Add the graphing, add the predicting. Those are the next generation science standards requirements, and those are the things that our educators and our industry people that are going to hire our students are looking for the ability to do. I'm Deb Newberry. I thank you very much for your time and watching this video.